All right, continuing our lesson on covalent molecules, we're going to talk about how each family is different. And it's going to start off, I need to do a little term with you, and that's called lone pairs. You're going to see some of these molecules, or some of these atoms have lone pairs of electrons. What is a lone pair? A lone pair of electrons is two electrons that take up a bonding site so that no bonding can occur there. And so what you're going to see is treat these things like a space station. Okay, and so that when you're in a space and there's a space station there, and all these spaceships are coming, there's a place you can bond there, there's a place you can port there, there's a place you can port there, and so these spaceships can come in and they can port in those different spots. Okay, well just think of bonds and atoms like that. Okay, and a lone pair is basically like a place where you can't bond because there's already something there. Okay, and there's already something there blocking that bonding site. Well, that's called a lone pair of electrons. A bonding site is a place where one electron is available to share, and so a bond can occur there. All right, so let's look at each family and see how they're different, because every family is going to bond differently, and that's how we're going to determine what bonds they make and how they look. So the first family is hydrogen, just by itself. In hydrogen, you can see it has one valence electron, and so it has one bonding site and 0 lone pairs. Now, because it only has one bonding site, it's easy. It can only make one single bond. So you're going to see hydrogen can make one single bond with itself, or it tends to make single bonds easily with halogens, because halogens also only like single bonds. So that's obviously polar because it's two different nonmetals. That's nonpolar because it's two of the same. Now, we're going to start over here with fluorine, okay, the halogens, because the halogens are just like hydrogen and they only have one bonding site. So because it only has one bonding site, it can only make one bond, all right? And it can only make single bonds. It has 3 lone pairs, so you can see 1, 2, 3 lone pairs that are blocking those bonding sites, and then it has one site where it can bond. So it can only make single bonds. If it bonds with itself, it's nonpolar. If it bonds with another halogen or hydrogen, then it's going to be polar. We already talked about polarity. Now, oxygen. Oxygen has 2 bonding sites, 1, 2, and 2 lone pairs of electrons right there. So oxygen can make a double bond where it shares 2 pairs of electrons, or it can make 2 single bonds, and it's going to look like that. Okay, we're going to go over geometries later, but that's called bent. All right, so we've got two single bonds here or 1 double bond there. So that's the kind of interactions that oxygen will make. Now, what's it going to make single bonds with? Hydrogens and halogens is what it's going to make single bonds with. What's it going to make double bonds with? Well, all of its family loves to make double bonds. Oxygen, sulfur, selenium, and tellurium all love to make double bonds. So it's going to tend to make double bonds with those. Nitrogen's family has 3 bonding sites, 1, 2, 3, and 1 lone pair. And so because of that, because it has 3 bonding sites, it has to make 3 bonds. And so it can make 1 triple bond, it can make 1 double plus 1 single, or it can make 3 single bonds. So if it makes a triple bond, it's going to do that, tend to do that with its own family, like nitrogen and phosphorus, and they love to make triple bonds because then their full octet is good. Okay, it's going to make double bonds with oxygen's family. So sometimes you're going to see a nitrogen double bonded to an oxygen and then have a single bond to a hydrogen or halogen. And then it likes to make single bonds with hydrogens and halogens. So you're going to tend to see that, a nitrogen with 1 lone pair and then hydrogens and halogens single bonded to it. And it can make 3 of them. And we'll talk about that interaction and what it looks like later. Carbon's family has 4 bonding sites, and that's why carbon is so famous, and so it has its own branch of chemistry called organic chemistry, because it can bond so many different ways. It has 0 lone pairs. So carbon is like the best space station ever. It's got 4 bonding sites. It wants to, bring everybody in, all right? Because it can bond 4 different times, and it has to bond 4 different times. So how can you make 4 bonds? Well, you can make 1 triple and a single. That's 1, 2, 3, 4 bonds. You can make 2 double bonds. So 1, 2, 3, 4. That's 4 bonds. Okay, what's it going to make triple bonds with? It's going to tend to make triple bonds with nitrogen's family, single bonds with hydrogens and halogens. What's it going to make double bonds with? It's going to tend to make double bonds with oxygen's family, Okay, what's it going to make? It could also make a double and two single bonds. Usually it's going to make a double bond with oxygen and then a hydrogen or halogen to make the other two single bonds. Or it can make four single bonds. If it does that, that shape is called a tetrahedral. We'll talk about that later. And it looks like that. So it's four single bonds. So carbon has to bond 4 times. Okay, so these are the different combinations that it can do that. A triple and a single, 2 double, a double and 2 singles, or 4 singles. Boron is a weird family. It's kind of like a weird uncle. So it has 3 bonding sites, 0 lone pairs. Right? And so it only makes single bonds. It does not follow the octet rule. So it's not going to have 8 around it. And so that's why it's weird. Okay? And so when you see that, it's going to have 3 bonds to it, and it's always going to be single bonds. All right? So that's it for how each family is going to bond differently.